All right, so we are making a answer key for review questions. If you are a little rusty on this, hopefully this helps, but you may have to go back and practice other questions, although I do have a lot here, so hopefully that helps. So classic kind of AP setup, let R represent the area enclosed by these two graphs, right? First things first, let's graph them and let's find all the points so we know what we're talking about, right? The second one here, h of x, is basically y equals x. So I am going to put this a little bit tighter, so it's going to look a little bit like on a weirder slope. Something like that. And that's h of x. And the other one is root x plus 2. So that starts up 2 and does that kind of funky curvy thing that the root x does. So this is g of x. It hits here at 0, 2. I might need that. I might not. We'll see. They want the area of R. So that's this area here. I'm just going to actually write an R in. Yeah, I think I'm going to regret coloring it in later. I'm probably going to need this at some point in time. So let's set them equal. Root x plus 2 equals x. I want to get this alone. I think it would make my life a lot easier. Root x equals x minus 2. Square both sides. X equals x squared minus 4x plus 4. X squared equals, whoops. I'm going to subtract that x over. X squared minus 5x plus 4 equals 0. And I moved it all over to the left side because I'm a nerd and that's where I like it. X minus 4. X minus 1. So that means it'll hit at 4 and 1. Well, it clearly does not hit at 1. So we're going to cross that out. What that is when I squared this and made this x equals y squared. So this actually comes all the way down around. Comes all the way down around, hits again down here at 1. We do not have to worry about that. So x equals 4, which is nice because I can then write in 3, 4 like I knew what I was doing. And go 4 comma, and since it's y equals x, it's going to be 4 comma 4. Do I need both points? Maybe, maybe not. Couldn't hurt to write it all out. All right, so how do I find the area? That's my little hatching break for area. Area equals integral. We're on the x-axis because we don't need to change to y. G of x minus h of x, because g of x is on top the whole time. So we get integral from 0 to 4. My handwriting is probably going to get really small now. I'm going to write my radical x as x to the 1/2, so it makes it easier for me to integrate. Minus root x minus 2. I'm going to distribute that negative. And I just made a mistake, I think. No, that looks good to me. Oh, I got the wrong one on top. One second while I sort this out. What a mess. Okay, it's root x plus 2 minus x. Very weird. Let's go with this minus x dx from 0 to 4. Root x plus 2 minus x. Don't know why I had to make that so difficult. X to the 3/2 is 2/3. X to the 3/2, we add 1, divide by it, plus 2x minus x squared over 2 from 0 to 4. 0 is going to drop away, which is nice. We basically just have to plug in 4. That's going to be 2/3. Square root of 4 is 2. 2 to the 3rd is 8. Plus 8 minus 8 minus 0. Hey, that's convenient. So we just get 16/3. This is a moment where I would put all this into your calculator and use the math math 9 and set all this up. Actually, I'll do it the one time. 0 to 4 square root of x plus 2 minus x Notice how long it takes. 16 divided by 3. Also notice it's not perfectly precise out of the details here because it is doing a numerical approximation, but it's nice to know we did it right. Cool. Onwards. Find the volume of solid made of squares coming up out of the XY plane. So this is a continuation, which is a dangerous thing to do for an AP test. They don't usually just continue. They'll make it clear. So I apologize for not making it clear here, but I'll draw it a little smaller. They're saying these squares are coming up as I desperately try and draw them somewhat to scale. Don't know what I'm doing. I do know that the area of X, these squares, is just the side squared. And I do know that the side is the top minus the bottom. So root X plus 2 minus X squared. That's nice. Now, it's kind of a mess to FOIL this out, so I'm just going to do it very quickly here based on work I've done before. I get X squared minus 2x to the 3 halves minus 3x plus 4x to the 1 half plus 4. If you don't believe me, go ahead and FOIL it out. Actually, you should on your own anyway. So here we go. Volume is just the integral, still in the x plane from 0 to 4. This whole mess. X squared minus 2x to the 3 halves minus 3x plus 4x to the 1 half plus 4. And now you just have a hassle on your hands, not the end of the world. I'm actually going to do it even though I don't want to, because you should be able to do this. Hopefully you have remembered how to do this from your last semester. Zero to 4, all the zeros drop out, and we get a big ugly number. Should get 136 over 15, or if you were to reduce that to a decimal, 9.067. Reminder, we go to 3 decimal places in AP Calc, because that's what they're going to do on the test. Check it with a calculator. That's what I would do. Now they want to find the volume of a solid made of squares coming up with the diagonals of the, what the, oh, for goodness sakes. So draw it roughly again. Now, dot, 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 dot. Square comes up, dot, 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 dot. The diagonals are in the plane. Square comes up, dot, dot, dot. Dot, 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 dot. Almost impossible to see what the heck I'm talking about. All right, well, I don't know what's going on. So let's draw a square where the sides are like this. Oh, hey, I know this. The areas of this square is side squared. Well, I know what this line is. It's the top minus the bottom. This is g of x minus h of x. Well, we'll come back to that. Let's just call it d for now. All right, if I know d in a square, how do I know s and s? Now, I could go and do a long-term Pythagorean theorem, but we're smarter than that because we know it's 45, 45, 90. To go backwards, we just divide by side. So this is d over root 2 squared. Interesting. Looking at my old notes there, which is just d squared over 2. So the area, pardon me. Wow, did I really write area? That's bad. Volume equals 1/2 g of x minus h of x squared dx. Well, finally some good news. It's about time. We already did that. So the volume of this one, which is 1/2 36 over 15, which would get you 68 over 15. Acceptable. Or 4.533. Also acceptable. Notice we already did all this nasty integral calculus up here. That's where these numbers are coming from. Crazy. Okay. Onwards. So still the same problem. Revolve the region R around the x-axis. This is difficult to draw. Something like that, where this is a circle. And then there are circles here. We can't see the back. There's a circle here. We can't see the back. Maybe we can. And then a tiny little circle here and a bigger one here. And then a bigger one here. Oops, that's supposed to be dotted. You get the idea. It's a washer. Okay. So all I know for a wash is that the area is pi outer washer minus inner washer, everything squared. All right. Let's plug them in. The outer washer is g of x, so that is root x plus 2 squared minus the inner washer, which is just x squared. To find the volume, we integrate. Notice I throw the pi out front because it gets in the way. This mess. All right. I'm going to go up here and say that root x plus 2 squared is equal to x plus 4 root x plus 4. Then I'm going to go down here and I'll integrate integrate all that nonsense. So we get x squared over 2. That's that one right there. That's x to 1/2, add 1 3/2 divided by 2/3, 8/3, x to the 3/2 plus 4x minus x to the 3rd over 3. That's this piece right here. 0 to 4. Gonna keep it simple. We get 24 pi. Oh no, do I leave pi in the answer? You can always leave pi in the answer on the AP test. The only reason you would want to put that in a decimal is if it was a calculator question and they had a decimal answer, whatever. I would double check this one, make sure you're happy with it by doing it on your calculator like I showed before. All right, now revolve region R around the y-axis. The what? The y-axis. The what? Yeah, the y-axis. This is so hard. Oh no. From 2 to 4. 2 to 4. Hey, wait a minute. I only need one curve then, because that's from here to here. Create a revolve in the region R. Oh, wait a minute. No, it goes all the way over to there. I'm so confused. Well, welcome to the club. So let's see if I can make some sense of this. From 2 to 4 for y. This is 2 to 4. No question about it. Then there's a little chunk here, but it stops. I'm not going to show the rest of it. 2, 4. I'm going to regret putting those in there. We revolve that around the y-axis. Wow, I just lost my recording. I hope I didn't lose too much of it. Apologies for that. I would start this from scratch, but I don't have time. These things take forever. Anyway, so it looks like something like this region, where this is a circle, this is a circle. Looks like a washer problem. I gotta write everything as x equals. So first one's easy, y equals x, so that's just x equals y. Piece of cake. Second one, y equals root x plus 2, y minus 2 equals root x. X equals y minus 2 squared. Okay, sure, whatever. So the outer one is this one. The inner one is this one. It's a washer problem, so here we go again. And if you write this as x, really wrong, but I'm not going to get that mad. The AP test might, although I never see the AP test do this problem because it's just a little bit too much. So the outer one, like I said, is y squared minus the inner one, which is y minus 2 squared. Wow. Alrighty, and then volume is pi integral. Careful here, we're in the y world now. 2 to 4. If you're groaning because you know you have some nasty math in your near future, me too. Y squared minus. Just crashed again. I hope the recording is still going. It says it is. Y minus 2 to the 4th dy. You're probably saying, wow, I have to distribute that out. Well, there's no chain rule issues here, and we're integrating, so it's the opposite of the chain rule. It's the other operation. But I think we can just do this. Y to the 3rd over 3 minus y minus 2 to the 5th over 5, 2 to 4. Oops, did the 2 first. 4 to the 3rd is 64. Minus 32 fifths. Minus 8 thirds. Minus 0. Equals 184 pi over 15. Or the decimal equivalent. That's most likely a calculator problem. I'm not trying to show off. It's just that I tend to do everything by hand for the practice, and because students want to see it. All right. Revolve the region R around the line y equals -1. Why must you torture me? All right, so this is back to the X world. I'm going to leave a little space here. This and this. Yeah, we've seen that before. Now we go down here to y equals -1, and we revolve around that. Now, the rest is just a picture for the sake of showing a picture. It's a washer problem. Great, got it. Darn it, here and here. I'm not going to draw any more because I need it. The inside of the washer is this distance. That's just 1. Plus this distance. That's x. So the area, or in the x world again, pi, I did the inside one first, minus x plus 1 squared. Slow down to make sure your brain can wrap itself around that. This is always x, y equals x. You call it y, call it x. It's y equals x. Cool, actually you should call it y. Because now you're going to say this one is still 1, and this distance is root x plus 2. I didn't leave enough room. root x plus 2 plus 1 squared. Wow, I hope I did that right. Hey, I did it right. Wow, that's shocking. Equals pi times root x plus 3 squared minus x plus 1 squared. Volume equals pi. We're in the x world again, 0 to 4. Oh, this gets ugly. I FOIL everything out. And then I combine it, this one and this one. Let's see if I throw it up here. Root x plus 3 squared equals x plus 6 root x plus 9. And then x plus 1 squared. Leave a little space here. Equals x squared plus 2x plus 1. So, wow, this is crashing a lot. So this is that minus that. These are all negative. Negative x plus 1 squared is negative x squared plus negative 2x minus 1. All right, I guess the biggest piece is the negative x squared. Negative 2x plus x is negative x plus 6 root x plus 8. Pi, negative x to the third over 3, x squared over 2, plus x to 1/2 is 3x to 2/3, 4. Wow, cool. 4x to the 3/2 plus 8x, 0 to 4, zeros all drop out, equals, let's cut to the chase, 104 pi over 3. That's pretty tricky stuff. Yeah, that's hard. Welcome back from break. Okay, a couple more here. Is it a lot more? Why this is problem 1, I have no idea. I guess the first part was just practice. Okay, so now you go and do problems on your own. Definitely a calculator problem. I'm going to go straight to my answers, just in the interest of time. All right. So what happened here? Top one minus bottom one. This is just area. There's no volume. I don't have to do all that nonsense. 0 to 2 is my x. Top curve. You might want to graph this. See if you know what you're talking about. Bottom curve. Actually, this is the bottom curve. That's the top curve. Plug in 0. Cosine of 0 is 1. Negative 2 plus 3 is 1. So that's the bottom curve. That's the top curve. So top minus bottom. Math, math, math. 44/3. Now they do the whole, ooh, it's a bottom base of a solid. So what's going on here? Well, it's a square. Side squared. The length of the side is the top minus the bottom. Calculator. And I actually did it by hand too. Integrate from 0 to 2 the area. That's it. I'm going too fast. That's why we have a pause button if you need it. All right. Number 2. Some of the hardest parts of these is graphing them. So 1 over x does this funky curve thing. Y equals 1 is up here. X equals z is here. Find the volume of the solid when r is revolved around the x-axis. So it's a washer problem. The outer one is just 1. The inner one is 1 over x. The limits are from 1 to e, because that's where they connect at 1. How do I know they connect at 1? 1 over x equals 1, x equals 1. So you could probably write that down somewhere. 1 over x equals 1, x equals 1. That's what's. All right, blast it out, get this huge ugly answer. You could also do it in decimals. Apologize for the handwriting here. This happens when I write in a Word, it gets some really ugly, yeah, I'll leave it at that. Ugly looking stuff. Okay, now find when it's revolved around the line y equals 1. That's what I did earlier. All your radiuses now basically have a plus 1 on them, 1 plus 1, and a 1 plus 1 over x. Off you go, 3e plus e to the negative first minus 6 times pi. A little bit of math up here where I distributed out this to make my life easier when I do the calculus. Base of a solid, semicircle. Pi r squared, have to divide by 2 because it's a semicircle. The radius is the difference between the two, which is 1 minus 1 over x over 2. Why is that there? Oh, because that would be a semicircle. Yeah, that's half. I'm saying basically this distance, we want half of it because the semicircle goes all the way. Whew, brutal stuff. Math, math, math. Here's your answer. It's e to the negative first, not to some funky v. Do you remember trapezoid rule? I sure hope so. Constant gaps, 50, 50, 50, 50. We can go 1/2 50. The first one, double the second, double the third, double the fourth. The last one, 120. Blast it out. Don't forget your units. No, I haven't had any units in any of these other problems. Number 4, find the area. We got to do it twice. From -3 to 0. How do I find the zeros? I put them together. -3, 0, and 4. -3 to 0. Blast it out. Probably a calculator problem, but if you decided to do it that way, there it is. Perpendicular. You're going to see a problem just like this on your quiz, so make sure you know what you're doing here. Squares with the diagonals. I don't like this drawing. It doesn't look right. I don't like this one either. All right, it's the diagonal. All right. This may be wrong. I don't like it. We should have a square here. D, S, S. S equals D over root 2. D is this minus this, also known as 2 times that. There it is. Then we should have a, when we square this, should be this diagonal over root 2. Oof, that's so disappointing that I did this wrong. Oh well, these things happen. Yep, that's the diagonal over root 2. So we square it, we get 4 over 2, we get 2. So this is 2. This is 2. This is 4096 over 3. This is 1365.333. Well, nice to find mistakes, and that's why you draw pictures so you can see them. Wow. And a couple extra problems just to practice for the quiz because you will see them. Car accelerates at rest. What's its velocity? It was at rest, so the velocity is just the integral. Plus 0 out here because its initial velocity is 0. Boom, done. Got to watch out, miles per hour per second. So you integrate from 0 to 4, seconds cancel, you're left with miles per hour. And find the exact volume of the solid following this region about the y-axis. So now it's going the other way. So you have this written as x, great, you don't have to do any math. 0 to the power of 4, that thing squared, because these are all circles. Pi r squared, sine of 2y, which is easy. This is easy when you square it out to integrate. And you get pi over 2, also known as 1.57. Oh, that's so bad. One, 1.571. Oh, the shame. And then when it's bar, go moving to the right, to the left, and stop. The graph's always negative. It's always moving left. When you graph it, you see that you're always below the line. It's always got negative velocity. That's it. Hope this was helpful. Wow, that's a lot of work.